Okay, these notes that we're going to be taking here, or I should say that you're going to be watching, and hopefully you take notes from what I do in this video. Uh, this is my kind of way of replacing in class lecture when I would be standing up in front of the lecture room and writing on the board and discussing things. Well, you should kind of, whatever you would normally do in that situation, you should probably do here, which is take notes. So I kind of call these note lectures or notes, or, this is a general idea. So whenever I talk about the notes, I'm probably talking about the notes lecture. And you should probably take notes from this just like you would in class. The topics are similar to what we will see in PowerPoints and things that I go over that are from the book, but they won't be exactly what's in the book or on the PowerPoints. They are things I've added, things that I think are important. This is really the more important parts to watch because you get to see what I think is important, and I often give hints as to what's going to be on the exam. So these are probably the more important lectures, not like me going over PowerPoints or what's in the book. It's probably these lectures here that will be the more important ones. And of course, you should watch all of the lectures, all of the videos I put out there. But what I will do is I have kind of an outline. These are the kind of topics we're going to talk about in this video. And I'm going to write some things down here, just like I would on a whiteboard, a chalkboard, or whatever. And you take notes. I suggest you write down everything that I write down here in your notes. So if I write something, I would say you need to write that as well. But you should supplement that with ideas. I'm going to be talking as well. And as you process this information, you need to write down your own personal notes that kind of explain things in your words along with what I write down. So, personally, what I would do if you're looking to make a really good grade is that you would go through the video one time, copy down everything I write down, and listen to everything just once with the kind of the idea of I'm just going to sit back and relax and take it all in, but I am going to write down everything that the professor, me, writes down as well. All right, and then after I have that kind of outline and all the things that I said in your notes, go back and watch it a second time, but this time over on the side in the margins or something, you write down your ideas as you go along, your interpretation. What does this mean to me? That sort of thing. And how are you going to remember it? You should always be taking notes with the idea that what I write down is one thing, but how you think about it, that's another thing. And the ideas you have when you listen to me talk, those are also, you formulate your own view of what's going on, and you need to write down that as well as what I write down. So you need to have everything I write down, but then you should probably go back and watch this video and watch it again with all the things I wrote down. But then you should also write down your comments or your ideas about what this means to you, and that will help you kind of crystallize the concepts in your mind, but they'll be in your words, not in my words. And when you see this a week later or 2 weeks later or a year later, the way you phrase things and the way you remember things will bring back the concepts to you a lot quicker than if you're trying to reinterpret what I said, because your brain is like a filter, and it takes in the things I say and rearranges them and then creates some concepts that are familiar to you and that are easier for you to draw from in the future. And so, in my opinion, that is the best way to take notes. And even though I prefer in-class lectures, when you have videos like this, you can go back and rewatch these, and so you have time to jot all those little ideas down that you have as you go along. You can pause the lecture and write down everything you want in between the concepts that I'm putting out there. So I would suggest doing that. I would suggest going through and just listening to it once and making sure you write down everything I write down here. And then I would go and do it a second time, but pausing and kind of writing down your ideas as you go along. Ways for you, you have to learn to do this. This is what really good note taking is being able to take the lecture in and convert it into a sort of a shorthand language that you are able to, shall we say, understand better in the future. In other words, you have your own your own way of thinking, your own way of converting my ideas into things that are easy for you to remember and understand through your experience. All right, so let's get started. We will start here with what is science, and I'm going to ask you this kind of concept is, what is it that makes science different from other activities in your life? Like if you're an accountant does something similar to science. An accountant will gather data, and an accountant will do some analysis, and they'll give you an answer. But how is this different than what a scientist does? Well, certainly, science does several things similar to an accountant, let's say, and that would be, for instance, gathers data, observations, if you like that. Oops, I jumped. Let's see here. Gathers data. And, let's say, and there's math involved. A lot of people would say, hey, there's math, you gather data, you do observations. All of those things are things you would do as an accountant. Accounting must be a science. And no, accounting is not a science. It's a profession. There are certain things you do, but when you're doing accounting, you're not doing science. So what else is there that you might be doing, all right, in science that you don't do in accounting? Well, there are several things you do. You form hypotheses and things like that, and we'll get to that. But the number one thing that I want you to remember, and if I ask you a question, for instance, what is science, or what makes science different than other things, your primary response, maybe not everything you would answer, but the main thing that's going to get you most of the points on that question is going to be that scientists do experiments. This is what sets science off from other fields. In other words, you have an idea about how the world works, and you've observed everything, and you may have even done some math kind of analyzing what you've observed. But you really haven't done science until you've done an experiment. In other words, you have to test to make sure that your idea of how the world works really works that way. You've observed it, but you haven't gone out there and kind of used it to change things and see if things turn out the way you think they would if you control it. This is what makes science different than other fields. In other words, an accountant might do an experiment, which would make them a scientist if they do it. For instance, the accountant says, if I add this up in a different way, I say it this way and put the numbers in this way, that my client will get arrested by the IRS. I don't know. The IRS doesn't arrest you. They just take money directly out of your bank account. But if I were to do this and tell my client to do this, and they did it, they might get in trouble with the IRS. So they do this, and then lo and behold, they don't. The IRS says, "Oh, that's fine." Well, that experiment would have actually been a very successful one, even though your hypothesis was wrong. The hypothesis was, if I do this for my client's going to get in trouble, and then they don't. Well, you've learned something there, and technically, that accountant has done some science. They've used they've done an experiment. Now, it could also work out the other way. You think you're going to save your client some money, and instead, your client, gets fined by the IRS instead of saving money. That would be an experiment with a different type of outcome. And then you might do it correctly. Your concept, your hypothesis might have been correct. I do something, and sure enough, the IRS says, yeah, that's fine, and therefore you thought you would save your client some money, and you did. So an accountant could be a scientist, but if you're the client, I don't think I would like my accountant being so scientific. To tell you the truth, that would, though it would be great if he saved you money, or she, but the idea here is you generally don't want your accountant to be doing experiments with your tax return. Okay, so you should get this idea and make sure you kind of understand what the key thing in being a scientist is, and doing science. There are lots of things involved in doing science, but the main one that sets you apart from other professions are experiments. Experiments, and feel free when I ask you a question, maybe on this, and maybe it's an essay. Feel free to use this accounting example. You can say, hey, if you were an accountant, you really don't want to be doing experiments with somebody's tax return. That might, you'd lose a client there. They might even take away your license to do accounting. I don't know. It would be funny. All right, now, well, these things that involve experiments, etc., that are different from what most people do in their professions, this is called the scientific method. And there are lots of things involved in the scientific method. We're not going to go into a lot of them here. But you do need to observe the world, so that's more like gathering your data here. You observe things, jot down some notes, gather data. All right, that's part of the scientific method. You also need to do something called, all right, induction. Okay, now induction is kind of where you create generalizations from the things you observed. You observe a lot of things, maybe you're watching birds, and you decide that this one particular type of bird always does something. They do something all the time, and you think that that's like a defining thing of that type of bird. They fly backwards. I have no idea what they fly backwards at night. Don't think that's possible, but let's say that is something, and you're going to say that I believe that this type of bird always flies backwards at night. And that type of observation and making that generalization, the generalization that all birds fly backwards at night, that's induction. You have taken a few observations. You haven't watched all of this type of bird. In fact, that's impossible. You would not be able to watch all of these birds all of the time forever. So you have to do some induction. In other words, you can say, well, all of the time or most of the time they do this. And so I'm going to make this general rule that this is a defining thing about this bird. It flies backwards at night. Maybe it doesn't do it all the time, but it does it almost all the time, as far as you can tell. And that's called induction, and this allows you to form a hypothesis. And that hypothesis would be that this bird flies backwards at night, and you might even say it does it for a reason. Maybe you see that it does this strange behavior because maybe some predator can't catch it if it flies backwards. I'm making things up here, kind of absurd, but that's a good reason. You could say, I think it's doing this for a particular reason. And what you would be doing there, through your induction, you would form what's called a hypothesis. And hypothesis is kind of your explanation of why things happen. It's your theory. But the thing is, a good hypothesis, all right, needs to be testable. All right, so when you come up with a hypothesis, it needs to be testable, and that means testable in the form of you can do experiments. Oops. So you need to do experiments based on the theory you come up with, based on your hypothesis. And in the lecture notes, when I go through the PowerPoints, we'll cover this in a little more detail. It's important, but and maybe testable, but I would rather you understand this big picture part than the fine details. So once you have come up with an idea that I can test this hypothesis with some experiments, and you come up with some experiments, then you do those experiments, and you experiment and you change the world. All right, you alter some variable in the world, like you take the bird and you put it in a cage and you have a light in there, and maybe you turn the light on and it flies forward, and when you turn the light off it flies backwards, and then you do different things to try and see if you can get it to do what you want. And so you're now conducting an experiment, you're altering variables and such, and once you kind of test this and gather your data, all right, so you gather more data, you use deduction to essentially come up with a prediction on what you think your outcome is going to be ahead of time. So you have a hypothesis that you think the bird is doing something for a reason, so you try to alter the world in such a way to see if it will do exactly what you want. And it's kind of like you make a prediction based on your theory. So this is doing something called deduction. And this is when you make the prediction, and that prediction is based on your theory. So your prediction based on your theory, on how you think the world works. So you do induction generally in the scientific method first, and then you do some experiments, which are kind of your deduction, and you look to see if it actually works the way you want. So your induction is how you make up your theory, your hypothesis. Theory and hypothesis, pretty close to the same thing. So your induction is when you're kind of making up your hypothesis, all right? And when you do your experiments, you're designing those experiments based on your theory, and they're designed to predict something that will kind of prove your theory. And I really shouldn't use the word prove, because I really want to emphasize here, this will probably be a test question somewhere, is that you never can prove a hypothesis. You never, all right, I'm going to make that in big letters here, never prove a hypothesis. All right, oops, I jumped up there again. I hate doing that. All right. All right. Hypotheses are never proved. And we'll get into some details on what that implies later. But just keep that in mind. That's going to be important. It'll be a test question somewhere. I will ask you about proving a hypothesis. And if you ever see me write down prove a hypothesis like we have here, prove a hypothesis, you know that that's a trick question, really. You never prove anything with a hypothesis. In fact, most of the scientific method, nothing here is about proving things. It's all about generalizations, and you never prove anything with statistics. You never prove anything 100%, because you can never see all examples and all possible outcomes over time and space. So you really can never prove that it's always going to be that way, but you can say that the majority of time when I've observed something, I've seen it comes out this way. And science is really based on this. People use the term prove a lot, and let's wait for this plane to fly over. They use the word prove a lot, and they really shouldn't. because that's not what you do. All right, I'm going to break this up into two parts. This is getting kind of long. So this will be part one of our lecture on what is science, and I'll pick this up again later.